All right, so welcome everybody. This is going to be the first editions of our distance learning here for geometry. And the thing that we're going to do today is let me give you an introduction. Okay, so this is the whole Sandoval crew. We got Celeste, say hi.
Hi.
Alan, say hi. Okay, Max, say hi. Max, say hi.
Oh, hello.
Okay, and Marcus, say hi.
Hello.
All right, good. Okay, so these are all the Sandoval squad here in the Sandoval household. And today we're going to actually be covering circles and arcs. And the thing that's important about this is that we're going to go over some vocabulary terms, and then after that we'll do a few examples. So with this, Celeste, go ahead and read the first vocabulary term.
Okay. The set of all points that are from a given point.
Okay, so do you know what that blank is?
Yes, it's equivalent.
All right, good. Okay, now one thing that I am going to be requiring you to do is that we're going to go through all these vocabulary terms. You're going to write all these things by hand, and then you're going to upload it to the Google Classroom. So just keep in mind, so when you're going to write down vocabulary term, you write down circle, you write down the definition. It's optional if you want to do the illustration. But just to give you an idea, of when you hear the word equidistant, it just means that I could guarantee you that from the point P, and I go to the outside of the circle, okay, it's going to be the same distance no matter where I go, okay, which is the same thing as like a radius. Most people understand radius is, doesn't matter where you draw it, but it means that you're equidistant. That's how you make a circle. So you could take this point and just basically go all the way around. All right, good. Now, Marcus, go ahead and read the next vocabulary term.
Okay. The blank point that all points are equidistant from in.
Okay, I know.
I think it's adjacent.
Start with the actual vocabulary term.
The vocabulary term is center of a circle.
Okay, so then it's the what?
The adjacent point that all points are equidistant from in.
So you think it's adjacent? The
Yeah.
term? No, it's the given.
Given.
It's the given point that all points are equidistant from. The word adjacent didn't work is because adjacent means you're next to it. So this time it's a point, and then from there you make the circle from that point. Does it make sense? So, all right, good. All right, now, Max, go ahead and now read vocabulary term, read diameter, and then read what it says.
A segment that joins the point of a circle to another and goes through the.
What do you think that is? Here, let me help you. Goes through the center. Okay, so it's a segment that joins. So that's how you get a diameter. So like right here in this illustration, I'm going to retrace AB because that's the, let me see if I could try to move it up a little bit because I didn't go exactly through the center. But that's how you have a diameter. You go from side to side. All right, now let's, Celeste, go ahead and read the next vocabulary term.
The
The one that says radius.
The distance from the center of a circle to a blank on the circle.
Okay, so what do you think that is? Here, let me help you. So
The point.
the point, yeah. So we're talking about like this point P right here. And let me see, let me get to the highlighter right here. So you see that point P? That point P is you start from there, and that's how you go from that point to on the circle. That's what a radius is. So virtually, let me go ahead and redraw it again. So there you go. That's kind of like a radius. Imagine that line ends at the circle. Okay, Marcus, go ahead and read the next vocabulary term.
Central angle. The angle whose vertex is the blank of the circle.
Okay, so then in this case, it's going to be, hold on, let me hit undo. All right, blank is?
Center.
So, what is it? Yeah, so reread it again.
An angle whose vertex is the center of the circle.
Yeah, so basically, here, let me show you. All right, let's see if I could, let me go back to pen. All right, you see this right here? That's a central angle. So from the center of the circle, you see those two lines? This is central angle, so that's central angle. All these are central angles, so you see that? That's also a central angle. Here's another central angle. So it just gives you the angle from where it's at in the middle. Okay. Let's see, Max, go ahead and read the next one.
You know what's fine.
Maximus, the next one.
A chord is a segment that joins 2 points on a circle. Chords are congruent if they are blank in length.
Okay, here's a blank. If they're equal in length. So like you see these two chords? Now, you know how I could guarantee that these are congruent? I'm able to guarantee you that solution because you see these little lines right here? That means that they're equal. But going back to what a chord is just going from side to side. So you go from there, that's a chord. But the thing is that you're guaranteed, or one thing that a chord can't do, a chord is not allowed to go through the center. And does anybody know why?
Nope.
Okay, that's because otherwise it'll be called a diameter. So a chord, so that's the reason why it's no longer called a chord no more, it's called a diameter. So that's the reason why. So there's another chord. All right, so now let's talk about this next one. So let's read the next one, starting with the
A
term.
part of a
Let's
blank.
start with the word arc. So arc.
Arc. A part of a blank. Next is piece.
Okay, let's see what it says. Arc is a part of, hold on. Let me go back to pointer. It's a part of
A circle.
circle. So in this case, we're gonna go ahead and just do like here, like you see right here. Here's an arc. It's just part of the circle. That's what's known as an arc. All right, so now, Marcus, read the next one.
Semicircle. An arc that measures exactly length,
There you go.
180 degrees.
Yes, so half a circle is considered to be a semicircle. So let me give you an example. I'm gonna put it in green. T to R is a semicircle, half the circle. Okay, now let's, Maximus, go ahead and read the next one.
An arc that measures less than
I know,
180.
we'll start with the term. Start with the minor arc. Say minor arc.
An arc that measures less than 180 degrees.
No, I know, but you didn't start with the term. Start with the term. Say minor arc.
Minor arc.
Okay, keep on reading now.
An arc that measures less than 180 degrees.
Okay, so you knew what it was. Okay, so you all see this red one right here? This solution right here? Okay, that one right there is considered to be a minor arc. And that's because we all know that 180 degrees is half the circle or less. Okay, now, so let's read the next one.
Major arc. An arc that measures more than 180 degrees.
Actually, you're right. Yeah, so major arc is more than 180 degrees. Okay, so let me ask you this. Is the green one a major arc?
Yeah.
Is the green one a major arc?
No, it's
No,
a semicircle.
right? It's a semicircle, exactly. In order for it to be a major arc, it must be that it has to go all the way around. So like,
Major arc.
let me give you an example of a major arc. So let me take that away. Let me do it in blue. Major arc goes from here to, ooh, that's a bad one. Hold on, let's see if I could trace it going all the way around. So everybody see that? I went past 180?
Yes.
So that's a major arc. All right. Now let's go ahead and Celeste, read the next one. What does the next one say? Celeste, next one.
Yes.
This is that one. The adjacent arcs. Read that one.
The adjacent.
Yeah, adjacent.
Adjacent. The adjacent arcs. Arcs that arc on the same circle and share one common
Here, let me show you.
point.
Okay. Point, right? Okay. So even though it doesn't look that well, does everybody see this blue and red one? Okay. These are considered to be adjacent arcs. If it was drawn perfectly, the thing you'll be guaranteed is that these will be touching right there. You see that? So they're considered to be adjacent arcs in this case. All right, now let's do the next one. All right, so now on this one, all right, Celeste, oh no, not Celeste, Marcus, read the next vocabulary term.
An arc measure. The measure of the minor arc is equal to the measure of the blank angle.
Okay.
Central.
Yeah, so basically, the measure of the minor arc is equal to the measure of the central angle. So what it's trying to say is that, okay, so you know how we talked about that this is a central angle? Right
What?
here? You know how we spoke that this 50 degrees right here? So from side to side, that's a central angle, right? Okay, what it's saying is that this measure on the outside of it is the same, like the arc right here, RT. And let me change color of it, because then you'll have the benefit of seeing it a little bit better. So as a result, that RT is also an arc measure, which is the same as a central angle. Now, there is one thing they put over here. Hey, does everybody see what they wrote over here? Does anybody know what it means? Okay, this is what it's saying, okay? Now, let me review a few things that are important. M stands for measure, right? Now, you see how it says there's like a little arc up here, and it says TQR? The result of that is that it's trying to tell you that you're gonna be looking at arc TQR. See how I kind of pass all those points? Let me try it one more time. I'll go around T, Q, and R. Does everybody see that? Okay.
So this is a major arc?
That's a major arc. Yes, correct. The green one's a minor arc, right? But what it's trying to say is that you could find the measure of that red one, because you know how all circles are 360 degrees? You could go ahead and discover what the red one is by doing 360 minus the other one, which makes sense, right? So you notice how I kind of covered this a little bit. Yeah, that was 50 degrees. So guess what the measure of the red one is?
It must be 310 because 360 minus 50 is 310.
Exactly. Love it. See? So that from there to there is going to be 310 degrees. That's what it's saying. So that's the measurement of that arc on the outside. Okay. Now, Max, go ahead and read the next one.
The ratio of the circumference to the blank of a circle.
Okay, so I think when you on the video you came out, but pi. Okay, so pi is the result of this, right? So actually, it's a ratio of the circumference to the diameter of the circle. So remember how we spoke that how the Romans, or not the Romans, the Greeks, measured circles in diameters and divided them, and that's how they came up with pi. So this gives you an illustration of how pi is made. All right, now, Celeste, read the next one.
Okay.
Circumference.
Circumference. The blank around a circle.
So read it again.
The distance around the circle.
Yeah, so it's like perimeter above a circle. So it's just the distance all the way around. Now you have the benefit that most of you already know that. The thing that seems to me reminding is these two things, is the equations. Remember, if you do circumference pi times diameter, or 2 pi times radius, then that's how you get the solution. Now, the way they came up with this, or the reason why this is so important, is that if you take this equation, multiply by d, you see how you get circumference? So it's hard to measure a circle around, but it's easy to measure the diameter. So that's the reason why this became so powerful. All right, now let's go for the next one. Marcus, read the next one.
Arc length. The length of an arc is the measure of the part of the blank of the circle.
Okay, so here you go.
Is it circumference? Yeah.
So it's only part of the circumference. So in here, they give us these two important equations. And let me show you. One of them is here. This is the one you're going to use the most, but let me highlight it. And let me ask you, all right, do any of you kids understand what this equation means?
Well, So it says that the length of AB is the same as the measure as AB over 300 divided by 360
Mhm.
times 2 pi r.
Okay, so kind of to help us here, let me do this. If I took this out, what is this equation right here?
The circumference.
Circumference equation, right? So it gives you the distance all the way around, right?
Mhm.
Okay, now do I want the distance all the way around? And it says arc length right here.
No, you only want the arc length.
You only want the arc length, right? So basically, I want to erase a percentage of all this, right? I want to get rid of that, correct?
Mhm.
So what I want is I only want this amount right here, this percentage, right? And anytime you look for a percentage, you always divide what's going to be, right? So like, let's say that this was, here, let me hit undo. Let's say that this was 60 degrees, okay? What you're going to do over here is that this is when this takes effect because you only want 60 degrees out of the 360, and you'll get a percentage. Like in this case, you'll get that, oh, you're only looking for 1/6 of the total circle. So you basically eliminated everything I just erased. Okay. Does it make sense? No? Okay. Let's go ahead and kind of review what's happening here. Okay. Can somebody tell me if this was not 60, if this was 360, what it meant?
It meant that the arc
Whole
length is
circle.
the circumference.
The circumference, right? Because of the whole thing, right? But I'm going to remove the 3. Okay, so as I remove the 3, what did I just remove? How many
300.
degrees? I removed 300 degrees, right? And I only kept 60. So instead of figuring out 360 degrees of 360, I'm only figuring out 60 degrees out of 360, which is 1/6 the size. So it gives me part of it. Does it make more sense now?
Yes.
Okay, good. All right. Now let's go ahead and practice some of these. All right. So for this next one, Celeste, read what it says, arc addition postulate. It says right here, the
The
measure.
measure of the arc formed by two adjacent arcs is the sum of the measures of the two arcs.
Okay, so in pretty simple terms, it's just saying this. Okay, so this plus this equals the whole thing, the one in blue. That's all it's saying. Okay, so very easy. Okay, so now let's go ahead and now off this diagram right here, let's go ahead and name 5 minor arcs. See if I can remove ourselves right now. There we go. Okay, so, hey, so Celeste, let's start with you. Give me a minor arc.
A minor arc is
No, right here. No, give me this. Give me a minor arc on the circle.
so D and B.
CB?
No,
Okay.
DB, because it's half of it.
No, that's not a minor arc.
Get
That's
out of here.
actually,
Okay.
that's a
Thank
semicircle.
you.
Oh,
Okay. All right, but let's name a minor arc. Give me another chance.
CB.
Yeah, CB is a minor arc. That's because less than 180, right? Okay. Marcus, you name the next one.
D
D what?
to E.
DT. Good. All right. Yeah, that is a minor arc. Max, name another one.
For minor arc,
Yeah, minor arc.
BF.
BF? Good. Yeah, BF is another minor arc. Celeste, can you name, well, I'll give you the other ones. The other ones are EF, and which other one is missing? Do we do
CE.
CE? Oh, we hadn't done CE? Yeah, that's another minor arc. So I think there might be more, but here's the results. So if you want, go ahead and write these down. So when you're rewriting your notes, you write these down as well. So find the minor arcs, try your best to draw the circle. Okay, now let's do 3 major arcs. So we'll start with this time with Max. Let's give me a major arc.
CF.
CF is a semicircle. It doesn't qualify. That's 180.
CB.
Okay, say it again. I didn't hear you.
CB.
CB depends to the right or to the left. This, if you, okay, if there's ambiguity, okay, you always have to name the 3 points. So like, if you went to the left this way, that's a minor arc. Yes, Celeste?
So D to
CBF.
C, going to the right.
Okay, no, say again. DB what?
D to
CB.
C, going to the right.
Okay, so you say D, B, C. You name the 3 points. D, B, C. So you're looking like this. D, B, C, and you're showing that arc that way. Does it make sense? Because now you're naming D, B, and C. You're showing the direction of what the points you're hitting. Does it make sense? Okay, good.
Yeah.
All right, good. Marcus, name the next one.
E, B, C.
Yeah, EBC, good. That's another one because you went this way. Good. Maximus.
Mhm.
Maximus. Okay, name the next one.
EFBC.
Okay, so you just need to name really 3. So EFC if you want. Okay, but there's more than 3 here. They just wanted you to name 3. So here's the 3 that were written down for us. Okay, now let's go then to Celeste. Name a semicircle.
A semi. D to B.
Yeah, D to B, exactly. Yeah, because that's exactly 180. Good. And then Marcus, name the other semicircle.
C to F.
Yeah, C to F. Good. That's exactly 180. So here they are too. Now remember, they named 3 points because they wanted to show like here DCB, they went that way, and then DFB, they went this way. Does it make sense? So they show the direction that they're going right here as a result of the 3 letters. So you know which orientation you're going as you're doing the solutions for these things. Okay, now let's do the next page. All right, so now they want us to find the arc measure of the circle. Okay, so let's start with, now one thing that's gonna be important for us to do this, let me move this a little bit. All right, it's gonna, you see these blanks right here? Okay, so we know that this is 90 degrees. This is, you see the little, okay. Now what I want you to do now is this. If this is 90 degrees, Max, what do you think this one is? The one I have, I'm moving around right now. What do you think that is?
144. Wait, no, 190. 90.
Yeah, it's gonna be 90 degrees.
90.
Okay, it's gonna be 90 because this is 180, right? Okay, now Marcus, what do you think this one is? When I'm touching.
Are we almost done?
66.
Yeah, let's see. Yeah, you're right on 66. How'd you come up with that?
I added the 3 already existing angles, then subtracted them from 360.
Oh, wow. That's actually, you did more. I would have done, you see how from here to here, this is 180 degrees? This one right here, this is a semicircle. I would have done 180 minus 114, but your method works too, of what you did. Okay, so that's good. All right, so now let's answer these questions. Okay, so Marcus, what's under this first one? UT is.
You mean A?
Yeah, A.
Okay, so
How much is that?
that would be 114, right?
Good. All right, let's see. Max, do the next one.
For D?
Yeah, for B. What is the measurement of ST?
66.
Good. All right, so that's the next one. SB.
We're done.
Daddy, like all the things, I can't really see like the full circle.
Oh, it's a little hard to see it? Well, this is going to
Want me to
be.
show Marcus so that I can show him?
There we
But
go.
I'm guessing it's 150 since math.
No. You see this one in red? You see how it says that was also 90 degrees right here?
Yeah.
So that's 90. Because we're talking about that arc there. All right, Marcus, the next one, UV.
Also, that line to us. Okay.
90.
90. Max, VUT.
Wait, Daddy, do you want me to show Marcus what I'm seeing?
Not right now. Later. Remember, you're going from here, V, U, and T. So basically that arc. How much is it?
204.
204. Good. And then the last one, well, not the last one, but SVT, Celeste. Can you see it?
No, I can't see where the lines are.
S, should be right here, S, V, and T. Are you able to see that?
Yes.
Okay.
What part of it?
With the one I just drew in red.
Okay, so
So,
that
Celeste, let me help you real quick. You could grab the face cam and move it not on the circle.
how do you do that?
You grab it.
Oh, okay. So you have
Oh, wow. Okay, yeah.
Okay.
Thank you, Marcus.
okay. So now you're able to see it. All right.
Yes.
All right. So then you see the 90, 90, and the 114.
Yes.
We're gonna add all those together to get that SVT.
You got 294.
Well, actually, they did a little different. Yeah, it's 294. They actually did 360 minus 66 because they wanted the other part, which is another way to do it. There's more than one way to get the solution for these things. All right, now let me go and now let's scroll down. Okay, now this is basically the same thing, but now we have to find out what each of these boxes are. Okay, so now let's start with Marcus. Do you know what this box is? One, well, here, let me show you. This one, the one I'm kind of like, the one I'm moving around a little bit. Yeah, let me help you.
Okay, wait, no, I got that. 110.
Yeah, 110, good. That's written a little wrong. And then, and then Max, what's this one?
For B?
Yeah, the one I'm touching right now. You see the one I'm kind of like moving around in the screen? Which is that
70.
one? Yes, good, 70. Celeste, what is this one? Celeste, which is this one?
That one?
Yes.
That is.
Actually, we should probably, okay, so you see how this is 70? Okay, so this one, you see how this one's 70? Okay, this has to be total 110, right? Okay, now one thing that I know you haven't learned, Celeste, because you haven't been in geometry, is that these things right here, these means that both of these are equal. You see these little arcs? So that means that if you take 110 and divide that by 2, you're guaranteed that each of these results are going to be 55. Okay, so that's how we get that. So now let's go ahead and read each of these angles right here. So you see how it says measurement of EDI. So now in this case, we're going to be looking at this way. Angle E, D, and I. How much is that?
That's 70 degrees.
Good. All right, Marcus, why don't you go ahead and do the next one, which is the arc measure. Now this is a difference from arc measure. It's almost the same, but it just
110.
Yeah, 110. Good. Exactly. All right. Good. I think that's it for this one. Okay. Oh no, hold on. There's some more. Let me scroll down. Hold on. Let me move. Oops. No, I didn't want to do that. I'll move this out of the way for a second. Let me go back up here. Oh no, there we go. All right. So we are here. All right. Good. Okay. So let me move this back. And let's talk about this real quick. All right, so now you see how they want you to find the variable of each one, okay? One thing that you're gonna have to do when you do this is notice how this right here is pointed to this right here is pointing to this part right here, okay? Notice how you see, how much is the measurement of all that?
180.
180, right? So you could create an algebra equation setting both of those equal to each other, just as so. You see how it says 2a minus 45 plus a equals 180? Okay. Now, we have the benefit that you see how this one and this one are the same? There's a's in both. Okay. We're going to combine those together. So as a result, you're going to get the solution 3a minus 445 equals 180. Now, the next thing we're going to do is we're going to solve for a, so isolating a. So in doing so, I'm going to remove the 45. Now remember, when you solve, you know how you understand PIMDAS? please excuse my dear Aunt Sally, we do everything backwards. So we start with the subtraction first. So we add, we do everything backwards. So notice how I'm doing everything backwards? I add 45 to both sides. As a result, I get the solution that 3a equals 225. Now, since I have no more subtraction, I'm left with the amount that I now need to divide. So the next thing I'm going to do is I'm going to go ahead and divide that by 3 to both sides, and as a result, I get my A. Notice that? So my A is 75. All right, now let's do the same thing with the next one. Okay, now, does anybody have an idea how to solve this one?
Okay, well, 10a minus 4 plus 8a plus 6 plus 6a minus 2 equals 360.
Exactly, yeah, and that's actually what's here too. Let me see if I can move this a little bit. Oh, there we go. So you're right. So you notice how that? Now, notice how all of these right here are underlined. You know why they underline these?
Because they're common terms.
Yeah, so you could add them all together, right?
Mm-hmm.
So as a result, you will get 24a, and then what happened to the numbers? The -4, let me highlight the numbers.
Well, if you add them together, you get 0.
Yeah, exactly. If you add these 3 ones we just highlighted, you get 0, so there's nothing left. So then what would I do then to solve this one? What's the next step? What's going to show?
Divided by 24.
Yeah, divided by 24 because you want to isolate a. So as a result, then we get a equals 15 as a solution. Okay, good. All right, now let's go ahead to the next page. This is the last page right here. And it's very simple. They want us to find the circumference of the circle, and they want us to leave our answers in terms of pi. Now, does anybody know why is it important sometimes to leave things in terms of pi? Or why is it important to sometimes not simplify all the way out? Does anybody know?
Because pi is a bad number and you don't want to simplify it.
Well, so pi is an irrational number, not a bad number. It's actually really, it's the most important number in math as far as ratio-wise. But the thing that may happen, though, is that if you sometimes, I guess, estimate too wrong, okay, you may end up like doing something bad. Does it make sense? Like one time there was an airship that crashed in Mars because somebody did some bad math. Does it make sense? So sometimes they're going to ask you the most perfect solution, so you leave things in terms of pi. So here you go. So what's the 2 equations I should keep in mind when I do this?
2 pi r, no, yeah, 2 pi r and
What's the other one?
pi d.
Yeah, pi times d, the original one. All right, this is the original one. This is the one sometimes you're given. So we're going to apply each one. So which, you see the first one right here? So let's say, which one am I going to apply? The first one or the second one? It's actually going to be the, let's give her some help. Max, help out your sister. Maximus. Maximus. Look at it and help out your sister. Yeah, the first one. You're going to do this one because you see how this is a radius? Radius means it's half the distance. It's like from the center to the outside circle. That's radius. So as a result here, let me show you it's really easy after that. Oops. Hold on. Let me take away that. There you go. So here's the equation, right? Then you just put in 9. Now, since we're going to leave it in terms of pi, we're not going to involve pi. Like you're not going to put pi in the calculator. All you're going to do is multiply these 2. So I said, what's 2 times 9? So that's that.
My computer.
Oh, your computer's freezing? All right, Marcus, help her out. What's 2 times 9?
18.
18. So guess what the solution is going to look like?
Lagging.
18 pi.
Yeah, 18 pi. And they put an M because it's still meters. All right. Now, Max, now the second one, Maximus. What is the second one supposed to do?
What the heck?
Yeah, so we're going to use the second equation, right?
When did all those numbers come out?
What is the solution going to look like on this one? Yeah, pi times, so circumference is pi times diameter, pi times 15. You don't do anything with pi, so it becomes 15 pi, right? So we have those two. All right, Marcus, you did the last one. What should be the answer? Let's see. Okay, since we're losing a little bit, once we get better internet here, I'll go ahead and continue. Okay, so circumference on this one is pi times diameter. Okay, and in this case, we'll have 6.3 circumference times, well, it'll become 6.3 pi. All right, now let's go ahead and now do the next one. And now in this case, we're gonna actually discover, we're gonna go ahead and just use the equation pi times diameter. And then from there, we'll go ahead and get this circumference, which is 6.3 times pi. So we'll get this as a result of 6.3 pi. All right, now let me go ahead and scroll down. Now our very last example, and this being the one that is, it's easy to understand, but there is a process that goes involved. Now, the thing they want us to do is this. They want us to go ahead and find the length, find the length of each darkened arc, and leave it in terms of pi. So in order for us to do this all right, so let me ask Marcus, how would I find the circumference of the circle?
By timesing 9 by pi. Multiplying 9 by pi.
Well, close. 2 pi r, because it's a radius. So we would do something like this. So you're right, as far as using 2 pi. Now this is the thing. We were practicing right above that this results in 18 pi, right? Okay, but that's the whole thing that's black. Now that's not the part they want. They don't want the whole thing. They just want this little piece right here that I'm doing in red. Okay, so in order for me just to get a fraction of it, I need to express everything in terms of just that little piece. So you see right here where it talks about, let me move this more out of the way. You see this little portion right here that just talks about the 20 over 360, the one I just circled? Okay.
Yes.
That's going to be the fraction. So really what I'm doing is that I'm saying, okay, so out of the 360 degrees that's here, I'm saying, okay, I don't care about the rest of the circle. I'm going to delete the rest of you, and I just want your fraction of what that is. So what they do is this. They multiply in order, so what they do next is this. So Marcus, what's 20 times 18?
360.
Yeah, 360, right? Okay, so you notice how you got 360 divided by 360? So let's say, what is 360 divided by 360?
1.
1, exactly. So that's really just 1 pi that's left. All right, good. Now let's move on to the next one. So this next one, all right, let me move our cells for a second and move this thing so we can see our cells a little bit better. Okay, maybe I have to move it over here. Okay, all right, so on this one, so let's say if I wanted to find the circumference of the circle, what would my slide do?
You would do 10 centimeters times pi.
Close. Now remember, you see how this
Twice?
is a radius? Oops, hold on, let me go back.
Hmm?
Yeah, since you see how this is a radius right here? This right here, this 10, the one I'm pointing to?
Mm-hmm.
Okay. So we will use the equation 2 pi r, right? And then you put the 10 in there. So Marcus, what's the circumference of the total thing then?
20 pi.
Yeah, 20 pi, right? Okay, that's the whole thing. That means that if I went ahead and then encircled the whole thing, I could guarantee the solution of the whole thing is 20 pi. But I don't want the whole thing. I just want a fraction of it. So as a result, I go ahead and place this little thing here. You see how it says 90 over 360?
Mm-hmm.
This gives me that percentage. So Celeste, what's 90 times 20?
90 times 20
Yeah, I'll highlight the answer.
is 1,800.
800, right? Okay. And then Marcus, what is 1,800 divided by 360?
5.
5, exactly. So then this is how we get the result that the solution then becomes 5 pi. Okay, let's go ahead and move on and let's do one more of these. Hold on. There you go. And we use this instead and kind of scroll back up and then move ourselves out of the problem. And on this one, all right, so Marcus, which equation would I use for this one?
Pi times the diameter.
Yeah, exactly. So that part right there, pi times diameter, right? So if I do pi times diameter, what's the circumference of the entire thing?
15 pi.
Yeah, 15 pi, right? Okay. Now, Celeste, do I want the whole circumference? No, I really don't. Remember, you only want this little piece right here. Okay. But if I drew this all the way around, I could guarantee you that all that black is 15 pi. Okay. But I'm going to do something less than that. I don't want 15 pi. I want less than that amount. I'm going to basically remove this whole piece right here. Only find the fraction of what it is. So as a result, you see this 120 that's right here? I'm going to take that 120 and place it here and divide it by 360. And so this is like a third. It's like almost like a pizza. You know, you only take a third of a pizza slice. That's exactly what it means. So what they do, 120 times 15 is going to be 1,800. And then 1,800 divided by 360 is
5.
5 pi. Okay, good. Now let's read the example. Oh, let me see my little, let me make this, let me create one real quick. Put it down there before we see the solution so we can think about this question. All right, very last question. A bicycle has a diameter of 21 inches. How many inches will the bike travel after 100 revolutions of the wheel? Round your answer to the inch. So Marcus, how would you do this question?
Well, I would first have to figure out the circumference, which is 21 times pi.
Okay, great. And then
I would just do
so
it times 100.
diameter is 21. Okay, so you know circumference, right? You just went through this process. You figure out, okay, and what do you do afterwards?
Then I would times it by 100.
Okay. If I didn't know why, or if you had to explain it to Celeste, what would you tell her?
That I think I'll just overcomplicate it.
Oh, well, you just say that one wheel turn is 21, right? Oops.
Yeah.
Right, one wheel turn is 21. And 21 pi, just one wheel turn, right? And then if I do two wheel turns, that's 21 pi, right?
Yeah.
Okay. You would need a total of 100 of these, basically. So it's easier to just do 100 times 21 pi. And that's exactly what we do over here. Right there, where this is 100 times 21 pi. And then afterwards, this is one of the very few times you're going to multiply right here and actually come up with the rounded to your nearest inch, because you're going to get a bunch of decimals when you multiply pi into everything, since pi is your irrational number. All right. Well, thank you so much for joining us. Thank you, Marcus. Thank you, Celeste. Thank you, Max, for having us. Okay. We look forward. Next video will come out on Wednesday.
Thank you. Bye.
Bye.
My computer.